Recording? All right, a couple announcements. We asked to have a solution for homework 5. The grader's been a bit behind, has some projects, so probably won't get that out until after you do your peer reviews. And by the way, there are lots of different ways to do homework 5, so it's not like it has to be just one way, however the solution wrote it.
So like for homework 5, we only grade them based on the code, right? It's not based on accuracy.
Only based on the code, not based on accuracy?
Do we have to grade them based on accuracy?
Oh, no. I mean, because you don't know what the right answers are. You can see whether they're the same as yours or not. So, yeah, I mean, just do the 4 points. It's just looking at their code is right. Yeah.
And what if you think everything is perfect?
Everything is perfect?
I don't know, but maybe it happens. What do you do then?
Yeah, a couple people have said that. I don't know, raise your standards. Maybe okay, here's a more realistic suggestion. Some things might not be clear. You could phrase some of them as questions, like, I didn't understand this piece that you're doing. It looks really fancy, but yeah, and they don't have to be. They can be like smaller things if they're not. Ideally, with a code review, the point is to find the biggest problems, right? Not all these trivial little. Your commas are in the wrong place. Like this is what my advisor and I fight about. He's like, you put your commas there. I don't like where you put your commas. So. Yeah. Okay. All right. So there's been a lot of questions on the database for the USA Spending, the SQLite one, and rightfully so because there was no way to join the transaction table with the recipient table based on what we had. So I made a new database. It took 12 hours to build it. I mean, not for me to write the code, but for the code to actually run on the Postgres server. And that is being transferred as we speak. It takes a long time to zip up and transfer. All these things take hours when it's this big. Yeah, it's getting a little unwieldy. It's 100 gigabytes, but zipped up it's 25 gigabytes. So. Hopefully I have it later today. I just want to be clear on the grading, how it's going to be. I don't know what Canvas is showing you, but the homeworks are all going to be worth the same, 1 through 5. So when I do the final grade, I'll weight them as such. But homework 6 is much easier, so that's worth a quarter of that, and not that much to do. And then we'll drop the lowest. Questions? Yeah?
I didn't plan my project based on, because I assumed that all the points would be like, all the homeworks would be weighted equally.
Yeah, they are all weighted equally except for the last one, except for 6.
Should it be like, we brought like the lowest homework from 1 to 5 instead of like 6, because like 6 is not equal.
Yeah. I mean, for most people, I expect if you do almost anything for 6, you'll be all right.
Yeah.
Not saying that you should just slop it up.
Yeah, because my question is that I was sick and I couldn't do homework 5. So
Yeah.
So like if you brought like the lowest point of like this, I would like have less point than other people.
Well, let's talk about that later and see if make sure because you did something right.
I did it because I was like really sick.
Okay. Well, we'll talk about it later. Okay. All right. So I wanted to say a couple things about the project. And actually, maybe I'll just review this while we're... Yeah, so it can be really hard to work with these big, clumsy data sets, as we've discovered, especially with the open-ended type questions. Before, I was asking fairly focused things for you to do. But when you're doing your own thing, the sky is the limit with what you can do, which is both a good and a bad thing, because you could get stuck just kind of trying to understand what's there. And what's there is fairly complex. My recommendation for you in this case is to start small. For example, if you want to fit a model on the entire data set and do something, maybe start with a subset focused on one region, on 1 year, on one time, on one industry. Pick something like that, pull that subset out and get your analysis figured out and working, and then figure out how to extend it from there. Then you'll at least get something and have some idea, not just be stuck with the whole data set the whole time. Another reminder to make whatever you're doing, make it specific. Think about who's going to read it later. Like if you get it posted on the USA Spending website, if your whole report is kind of nebulous and they're not sure what you're showing, it's better to have it be focused and answer something specifically and conclusively. Okay. Speaking of conclusively, just do the best with what you have or what you are understanding for this. And there are cases where there's some doubt, so just use your common sense and state whatever assumptions that you're using. So here's an example of what you might say. We noted that the annual totals for total funding in the awards table are less than the aggregate figures provided by the Congressional Budget Office. However, since 2008, the numbers consistently aggregate to about 80% of those of the CBO, so we've restricted our analysis to this time period. That seems totally fine, because this is what we were kind of figuring out in office hours, right, Jared? Yeah, something along these lines. So I think this is totally valid. You're just proceeding as if it's the whole data set, but somehow the numbers don't completely add up to what you expect them to. So there's that. Okay. And as far as why the numbers might not add up and go just quite the way you think, here is the query that built the transaction table. So we have this transactions.zip table. I told you that I took it from the Postgres database that USA Spending provided. Yeah, right. Down here. I wrote something. No. Okay, but I'll at least show you what this is. So this is a SQL query. The Postgres database they give us, or that I downloaded. Were you able to do that, Rishi?
From Anson?
Not from Anson, from
the terabyte one?
USA Spending, yeah.
No, I have not in space.
Yeah, the 1 terabyte one. So this we have running on our server. Maybe I'll show you it if we have time later today. But so this is the query that builds it. So it's a materialized view, which means we have all these tables of all this different data that's somehow in this database. But this is the table, I think, that powers the website, because it's the biggest one and it has all these indexes, and almost certainly the ones that powers USA Spending. So this 2TS vector, so the basic syntax of a SQL query is select all these columns. So these are all the columns that are in our transaction file, like 60-something columns, all these different columns. Okay, select as it's changing them, and then from, select from, left join. So it's all going back to this transaction normalized table. Everything comes back to here, and everything gets a left join on that. So we can see all this as being a big enrichment of the transaction normalized table. it's bringing in all these other tables, and I think there's like 16 or 17 other tables that are joined into this one table. So that's a lot of joining to do. And this is why we really like databases. This is hard to write this on your own in a programming language. Adding a condition, where, and then it's ordering by something at the very end. So this is kind of an industrial strength SQL query to get your... What's that? Yeah, it's all one query. Yeah, there's some subqueries in it. So some of the features inside this query are subqueries, where you have a select. You can nest queries inside each other. So you can left join from a new table that you're building on the fly. Questions?
How did you rename the columns? The columns, like, how did you choose it?
So I didn't write this.
Ah, you didn't.
No, I did not write this. That would be presuming a lot more. But I just wanted to show you that this is the kind of thought that goes into designing these tables. And also it's why things that you think should add up might not necessarily add up. So there are thousands and thousands of hours of work to get it collected before it comes into this database, to collect the data from all the different places before it gets here. And then they do this is something that a database administrator or DBA would do. They would write this kind of query and optimize it and add indexes to it to make it go fast and all these kinds of things. Yeah.
I noticed they agree in everyone agrees, but what if they have missing IDs?
If they have missing IDs, which missing IDs?
Maybe you left join the agencies if they have the same ID, right? Like the top tier agency ID equals the top tier agency ID in another.
Yeah.
But what if they have someone is missing and someone has a file?
Yeah. So if they're missing, this is why we have all the nulls in the data essentially. So with a left join, if the key, when you do a join, it matches on the keys. When you do a left join, it takes all the keys in the left-hand table, which is this transaction normalized ID is what they're using in this first join. So if it doesn't find it in the right-hand side, then it's just going to put all nulls for that row. Yeah. Or for, yeah. A few other features are this 2TS vector. So this is a function inside PostgreSQL that does text searching. So when you text search for this company, it's looking for this. And Alex and Nikita, you were asking about this, to use it as kind of an indexing structure. So all it really is the same kind of text pre-processing that we did in homework 2. It's doing that for us. So it's not actually giving us anything beyond that. But still, that could be useful because we don't have to do all the text pre-processing. The coalesce, what that does is just take the first non-null value that it finds for each of these things. So we can read that as, okay. So in the first place, when it makes this as keyword TS vector, so this keyword TS vector will be a column in our data set. It's coalescing first the recipient name, and if it can't find the recipient name, it's going to the awardee or recipient ID, or the next thing, and the next thing, and so on. Another interesting feature is line 26, obligation to enum. This is something that is custom to the USA Spending. So they wrote a custom function that runs inside the database, which is really cool and also something you could experiment with if you want, but we don't have time to demonstrate it in class. But the idea is you move your function to the data instead of pulling all the database, everything out of the database into your R session, you move your R into the database. It can be really powerful. or Python or C or whatever. The case stuff is another, the more advanced SQL thing. It lets you do some conditional type of logic inside there. And okay, that's enough confusing you with this. Any questions on this big thing?
So many.
So many.
So many questions.
What's that? Yeah. Yeah, this is why stuff like formatting and version control really matters when you're typing these queries out. Yeah. So.
How much time would it take to have a query?
To run?
No, to write this query.
To write this query? I don't know. It really depends on, like, if you do this every day as a database administrator, you might be able to write something like this pretty quick. But like for me to go in and try to write something, it would take me a couple days, probably. I mean, and I can read it, but writing it is harder than reading it. Oh, and the reason I was looking at all this in the first place was because I couldn't figure out how to join the recipients in here. So we didn't have a key to join the recipients, and I wanted to see where is the key, how are they actually getting the recipients. And if you look for actual recipients, inside lookup recipients, so it's doing a subquery and it's joining to all these other tables that we don't even have inside the SQLite database. So this is what made it impossible with the SQLite database that we had. We would have had to put all those other queries and make it much more confusing, so I didn't want to do that. So the latest version now has 6 tables in the SQLite database, not 60, and they're all, hopefully we can figure them out. Okay, any other questions on this? And this is also why you should be like really nice to your DBA if you're working at a company where you have a DBA. They can help you out with doing this kind of thing or write stuff to help you get the data that you need to do whatever analysis you're doing. Okay. All right, let's talk about Hadoop and MapReduce. Oh, I'm sorry. Do you have any questions? General questions for the class about the data, about the project, anything? Yeah, Cheng Chen. Will I curve at the end? I will examine the grade distribution and determine if that's necessary. Yeah. So will I curve? Maybe. But only up. Okay?
Do you know what is the median age the median score in the classroom?
The score in the class right now? Nope. I looked at it midway through and it was actually pretty high after the participation, the first participation a few weeks ago. Yes?
Will we have a second participation score?
Yes. So get on the ball, Cheng Chen. Second participation. Yes. Yeah, each they'll be worth 5% together, as the rubric said.
We'll ask a question of Piazza.
Yep. Yep. Piazza.
What is anonymous to like classmates but not to the professor?
Jared, you asked a sufficient amount of questions on Piazza. But yeah, you're right. Some of them are anonymous to both. I'm not sure how that shows up. I haven't actually checked. I expect it works. But.
Is the new SQLite database available on the nodes, or do we have to?
Yeah, I'll put it on the worker nodes.
Will it be in the Scratch directory?
Yeah, the same place the transaction.zip file is. And I'll unzip it and put it there because it's 100 gigabytes and I don't want everyone to be doing that. Yeah, this afternoon. So I will put the database on the Scratch nodes, same place as the other data. SQLite. Cool. Yes? Extra office hour next week? Do people need an extra office hour next week? Yeah, we can do something. It's finals week, so things will probably be a little off. I'm just thinking. Olga said the administrative assistant said we need to move our office hours, so I'll send out an announcement. Yeah. Yeah.
So did you decide that you wanted to do on Wednesday and not Friday? You know, like the exam schedule for Friday.
Yeah, I think I'm going to move the date to Friday morning for the due date.
Morning.
Yeah. Friday morning. Because, yeah, then the TA and I will grade them on Friday. So, no late. So I will move this on Canvas. Actually, I'll just do it. Assignments. You should finish Thursday night, for sure. Final project. Here we go. Edit. Okay, Friday at 8. Done. It should notify users. Okay. Cool. That's nice.
So is it, should we, what is the format of the report?
Format of the report? I think I set it on that, wherever I linked to here. Report, here we go. Everything you need to know about the report. 5 to 10 page written report.
So if I want to do interactive data visualization,
Uh-huh.
can I include the Shibata?
Yeah. Whatever you need to make the interactive thing work. Ideally, it works publicly, such that someone doesn't have to download the binder and install it. Like if it worked to where someone could just visit a URL and see it, that would be ideal. But still, do a report if you do that. I mean, do a report saying what's going on and maybe showing some of the features, what you were trying to go for.
But should we show our code in the report, or just the results and then?
So all the code that you use to build it, just attach it in an appendix or just separate files that you can submit on Canvas.
Okay.
But it should be all the code that you use to get it done. And it should work too. Cool. Okay. More questions? Ready for Hadoop? All right. So we have a Hadoop cluster running on statistics upstairs in the statistic 4th floor of the math building. I have to get to it by going through a different server, so I'm using a proxy server to jump into our Hadoop server because the Hadoop is not available publicly. But here we are on a Hadoop server. So to be clear, I'm not on my local machine. This is me on our Hadoop cluster, the head node.
So we can't access Hadoop.
You cannot. No. You do not have login accounts to Hadoop. I thought one cluster computing environment was enough for the class. So we're doing Slurm and Gauss. You can use the same ideas, but we don't have Hadoop installed. But MapReduce is in the course description, and I recently learned that we actually have to, you're supposed to teach what's in the course description. So that's why I'm showing you MapReduce. Yes. Okay, so let's mess around with Hadoop. Some Hadoop commands. So hdfs dfs-ls. Let's run this over on Hadoop. Copy and paste. That's all that's going on. So here I'm giving Hadoop a command. I'm looking to see what's inside the Hadoop file system. And this hdfs, DFS, stands for Hadoop file system. So I'm on the head node, and it's looking into the file system and running the -ls command. So -ls is a flag for HDFS, DFS, but these commands, they basically look the same as the Unix one. That's all by design. ls is like ls and r. You ls and see what's actually there. So all these commands are pretty similar. So what this is showing us is that we have all these, and I've got all these written out so that you can see it. I'm just going to delete this, make this full screen. Okay. So look over here. So I've got all these files inside HDFS, and one that I put there, 2017, one called PEM. So this is a directory inside the Hadoop file system. So you can think of, well, let's actually look inside it. So HDFS, DFS-ls, actually DU. So remember DU command was disk usage in bash. When I do the -du-h, it's just like du-h, disk usage in human readable forms. I see what's inside the PEMS directory. Run this command, it actually takes a while, and it shows me all of the commands that are inside, or all of the files that are inside this one directory. This is the command I entered, and how big they are. So I have all these files that are about 100 megabytes sitting inside my HDFS system. I can bring them from the Hadoop file system into the head node where I'm at. So if I have some final result that I make, if I want to bring it back and analyze it, do something with it, I can do that. So let's get maybe this last one. HDFS, DFS-get, PEMS/, oh, it's already there. Okay. So I run that command, nothing seems to have happened, but I'm on the head node. I went to the worker node and requested that file from the workers. When we were doing this kind of thing on the cluster, we were doing it in a very physical way by SSHing to each worker node or using this srun to get an interactive terminal on a worker node. This is more declarative. I'm just saying get it. I don't know what worker it's on. I don't know where it's at. It's just some abstraction of some big, huge data file that's somewhere there. So I can look and see what these actual files look like. Let's check it out. And let's just make sure they're here, LSD04 star. So when I did this ls, in contrast to the HDFS one, I did a local ls. So I'm in just my bash on the head node, and I downloaded these two files. The first one when I was making sure that all this worked, and the second one that I did just now. Okay? The same techniques that we were using, like unzip-p. This is a gzip file, so I can use the g unzip command. do4 raw 2016. Let's look at this last one. I'll pipe it to head. Look at the first few lines. See what's actually in this file. So here's some big data file. And in the end, it looks like, it turns out, it's just a CSV file. This one actually happens to be. It can be in any format that you want. CSV is kind of a, so-so one. We've been working with it because it's easy and it supports the standard in and standard out. But I might want to use something like a columnar storage, such as ORC or Parquet. So what that lets you do is efficiently extract columns one at a time. I see quizzical looks.
What's the name?
Huh?
Can you write it down? The name of the file format?
The name of these file formats. So columnar, and this is an important concept, so I'll write it down. File format. So what they do is provide fast access to the columns. Examples are Parquet. HDF5 can actually be used like this. Avro. I think Avro and ORC. I'm not sure. I think so. Yeah, so basically, when we stream through this data, if we want to get like the 19th column inside here, we have to look through all this other data that we don't want over here and over here. With a columnar data format, each of these columns would kind of be stored as its own thing. So they provide fast access to columns, which is often what we need with a SQL query when we're selecting only 1 or 2 columns out of 60 or 100 or 1,000. So is this row-based or column-based file format?
Column-based.
This is CSV files and .txt files, everything that's all row-based. Unless you were to have each column on one line, but that would be really weird. So these are row-based formats. And they're often inefficient. They have their ups and downs, essentially. The nice thing about them is we can always append. We can append rows and observations to each one. So that's why most databases will use some kind of row-oriented format. For transactional databases especially. And then when you go afterwards to do your fancy analytics, when you need the whole column, you can switch to a columnar format.
So why can't you append to a column-based format?
You can. It's just more complicated because instead of just writing one row in one place like we would for this, you would have to append to each of the, in this case, 30 different columns. You have to find all those 30 different ones and append at the same time all together. So it's a little more careful. Got to be a little more careful with it. Yeah. Cool. Okay. So this is all fine and good, and we could write a MapReduce program that would operate on all this data, and it would work fine. But we're usually too lazy for that, so we use something like Hive, which is a SQL database that's written to write all the MapReduce stuff for us, essentially. So this is way more efficient in terms of how we are using our time. So we see this, instead of So I type the Hive command just like I typed SQLite 3, just like I type pSQL to get into Postgres, just like I type R to get into R. I have a Hive interpreter here. It is ready to start telling me about my data. Okay, so now I can start writing SQL queries. So if I want to do select count star from PEMS. So PEMS was a directory inside the HDFS. Before I went into Hive and I said that, hey, all those files that are inside that directory, they're all organized in a really regular format, so make them be a database for me. I want those to be a database. Consider that to be a database. So in this way, instead of me having to write all the nitty-gritty of traversing all of these files in parallel, Hadoop and Hive will do it for me. So I wrote the SQL select count star from PEMS, I press enter, and I get all this stuff spitting out at me. So this is Hadoop telling me that it's running a MapReduce job for me. Okay? And it's success, it says okay, it spits out my answer. And instead of just spitting out my answer, so the answer is 2.6 billion rows inside this data set. This is more than an order of magnitude larger than the USA spending stuff. So I would say that the USA spending, it's getting pretty uncomfortable to do on a single node. Like it takes a really long time. It's a big pain in the butt. But when you go another order of magnitude larger, which is what we have here, these systems really come into their own, and they're really helpful and necessary. And that's why we use them. So it did all that. I was able to write very simple SQL, and it got me the answer in under a minute. So what it did is stream through all those files and run something that's equivalent to my count star, counting everything that's in it, and create the MapReduce job for me. So all this SQL that you could write, not all of it, but I think most of it can be transformed into MapReduce jobs and run in these terms. Any questions? Yeah.
Is that number the number of files in the directory, or the number of rows for each file summed up?
These numbers?
No, the 2.6 billion.
2.6 billion? So that's the number of records in that table, essentially. So inside all of those files, each one has about 10 million, I think. And then there are 260 such files. Yeah, so that's how it adds up.
Pretty fast.
Yeah. Yeah.
So the Hive is the parallel version of SQL.
So Hive is SQL that runs on Hadoop. And it's one of such systems. There's a whole bunch of other ones. Impala and a few cloud offerings. Yep. And yeah, so here is where we actually see the map and reduce job. It had only one reduce job because all it had to do to count all the lines, if you think about it, for each file, they just count how big each file is and then just add up all the results. So the reduce step in this case is totally trivial. You just add up all the numbers. That's the total count. Okay. And then these other things are like this failed and killed. We have this, all these fault tolerance things. So if one of my disks were to actually fail midway through execution of this, the job manager would go back and restart it and make it run for me. That's why you have all these other things. Okay. Yeah, quick. We're all done. Any questions on Hive or Hadoop? Okay. Sit. Go out of all my SSH hopping there. Get out of it all. All right. I wanted to also show you some other kind of more advanced programming concepts that I never really got a chance to do earlier. Put them over here. Okay. All right. So this is R code, and this is the R code that I use to copy the tables from one database to another through R to make our SQLite database. I'm showing it to you because it has a couple pretty cool little features or ways to use it. So these are things I'd like you to at least be aware of. So my function is called chunk copy table. The only argument without a default here is from name. So I have to know where the database is coming from. But then here I'm using R's lazy evaluation. So I know the TA talked with you about it last week. Oh, and by the way, office hours during discussion this week, I made that announcement on Piazza. So if you have questions about your project, we're not going to do the normal discussion this week. Just go in and ask C10 questions if you need to. So the lazy evaluation, what is happening is I'm using the first argument from name to give a default to the other one. So to name, I'm copying from one table to another table. I don't want to have to think about what I want to name the new table. I want it to just default to whatever the original table was called. And that's how I've kind of designed my function. But I can pass in something. I can pass in a different name if I want it to be named something different. Okay? And in the same way, I can pass in a query directly to get the data where I want. So if I want just a subset of columns or rows, I could write that query and pass it in here. So this function signature is very flexible. It lets me call it in many different ways, and that's a nice thing. Another feature is the ... Who knows what's going on? Why would we want to do this? No, you can't see. So what's the ... doing?
That mean you can pass any other arguments you want?
Yeah, so any other argument. So I just put the ... here, and then we see it actually show up here. So that means if I want to add some additional arguments to dbSend query, I don't know what I will like to use later. Maybe it has some special tuning arguments or something that I want to add, but I don't know what they are. If I did know what they are, I could put them in here and give them defaults and have them pass through. But a better way to do it is to put these ... and allow basically someone to put anything they want inside there. So when you look at functions that are wrapper functions, you often write these for methods like plot or read.csv as a wrapper for read.table. If you look at the signatures for these, they often have the ... So that lets you, when you call plot, you can say whatever else you want, like line type equals dotted or whatever, color equals blue, without having to specify all the arguments in the signature. Questions on the ellipsis? And that's called an ellipsis, by the way. The ... You know how to do that in Python? Yep, star args, or star keyword args. Okay, so write that down. Python. You have star args. That's an asterisk. So this will do this unpacking in the same way. * keyword args. And you can look that up, but the idea is the same as the ellipsis. You just gather up all the remaining arguments and store them somewhere in some symbol and use it later. All right. The last feature is the on-exit. So what the on-exit is doing is I've omitted all the actual code because I don't want it to distract you. So there's all this other code. The on-exit says, as soon as this function finishes, regardless of whether it ran successfully or it failed, I want you to execute this expression. That's what on-exit does. So what I always want to happen is to call this line db clear result. I always want to say, okay, I'm done, db clear result, clean up all the whatever mess it was doing, whatever memory needs to deallocate, that kind of thing. This also has equivalent in Python that we talked about pretty briefly in this class. So that was Python. R was ... Python. So in Python, there's the with statement, the context manager. So what that does, anytime you're in a with statement, it knows how to close the file or do whatever you want when you're done. So you can write these context managers that will close the databases when you're done. And that's, often we're just using them, but when you write them, this is how it looks in R anyways. So regarding where I put this, where does this on exit, where should it be to be most efficient? Where inside the body of the function? Why don't I just put it at the very end? Why don't I just call that line before the function exits? Yeah?
Because you don't want to keep the result for more than you have to.
Because I don't want to keep the result for more than I have to? But if it was at the end, I mean, this is still running at the end, right? So the on exit means that this expression inside here will run at the very end. Yeah?
Is it because you might forget?
Readability? Yeah, that's pretty good.
So you open and then you say close right after that. So it's like really readable and you are guaranteed to not forget.
Yeah, I think that's a great reason. This is not the one I was thinking of.
Will that not run if there's an error that occurs before
Yes.
the on-exit?
Yeah, that's why. So if we had the on exit, if we had it at the very last line, if we had some error that happened before that, then the R interpreter would never see the on exit in that case. So it wouldn't know to run it. When I call the on exit immediately after where I do the action that I want to clean up, then anything afterwards, if it makes an error, I don't know where the error is going to come in or why it could happen. You know, it could be anywhere. So I want to do that as soon as possible. But Suam had a really great idea for a reason there. Any questions on that? Yes? Okay. More questions in general? Next week we're doing, oh, not next week. Next week is finals week. This is week 10. Next lecture, I'm going to talk about compiled languages and interfacing between them.
Which one?
I'm not sure. Probably Julia and C. And I might do Numba and Python. Just to show you what they are and what kind of speed-ups you can get and how to think about these interfaces a little bit. All right, if there's no more questions, then we're 10 minutes early.
spiritual background.